So let me start with this. So yeah, this will be a this package. So this data which we are working with is actually a part of this library nutshell. So once you install this, it will be there. So this is mainly a bird detail related data set that we have. So let's start working with it. So we have already had a look at the first five rows of the data. So this is how it looked like. So we have some null values here. So this actually shows the education of mother. So for few of them entries it is null. Few of them have 2 years of college, 2 years of high school. Okay. Now let us see the dimensions, so how it looks like. So we have quite a high number of data here. So we have around 4 lakh rows of data and 13 columns. So quite a huge data that we have to work with. So this shows the details. So let us look at what are the, so one thing I want to ask you. So here I have the command. So anyone would like to guess what it would look like? So this is my data set and the variable is date of birth week and I have tables. So what would be my output? Okay. So it will be a week wise distribution of total births that, yeah, week wise and count of birth that's taken on a particular week. So on first week, this many birth, first day of the week, this many, second this. So one thing that you can notice here is on the first day and on the last day, so this is a Sunday and this is a Saturday. On these 2 days, uh, birth are less, and on weekdays, birth are more. So it seems like there is something related to weekend and weekdays factor associated with the birth of a child. So let us look at in the graphical portion in charts. So here you can see, as we have seen in the data, here for the seventh day and the first day, so Sunday and Saturday, the number of birth are less compared to in the weekdays. And let me tell you also about this command of birth chart. So what it does, first you have to actually provide a table inside. So if a data is provided in a tabular format, then only this birth chart will take it, otherwise not. So you need to provide that in a table format. So that's why we have made it into a table and then provided in bar chart. So this is how it looks like. So in the Y label stands for this day of week, and also this is a frequency or the count that we have for each. Now let me make another table. So this actually shows that for which week, which are the kind of childbirth or the method of childbirth that has happened. So as you can see, for the first week or Sunday, this is C-section. Or for some reason, the childbirth for both, for C-section and vaginal, both have gone down. So let's say, so let us do one thing. So unknown factor is not of any use to us. So let us remove that and then work with the rest of the data. So C-section and vaginal, these are the two things which we actually need. So we have removed that. So for that, it was only remove the second column. So for that, I have removed the second column, and let's see. So I've only left with C-section and vaginal. So now let us work with the data and let's see. Uh, so here, what it has done is, so it has grouped them together. So red part indicates one of the factors, and this light green part, it shows the other, or let's say it's not red, it's even a pinkish type. So this is for the if I have two factors associated with it, so it will give me like this. So what if I don't want it in this way? I want them side by side. So for that, I can mention a clause of group equal to false. So it won't group them together. It will plot them side by side. So here I have, it has plotted side by side. And here also I can see that C-section almost remains same. Only on Sunday and Saturday it is less. A possible reason could be most of the doctors are on leave for Saturdays and Sundays. For this reason, this figure might have dropped down. So let's plot a histogram of weight of the child along with the deep ruler, or that means that how many birth, or was it a single, twin, triplet? So in this way, just make a, so it doesn't seem good. Let me show it like this. Yeah. So as you can see, so one thing that could be noticed here is, so if a child who is born with a born as a single, so weight of that child is quite high compared to other factors that we have. So a single bond, on an average, his weight is quite high. For a twin, it has dropped down a bit. For a triplet, after, for a childbirth, it has reduced even more. Quadruplet even more, and for higher factors it has gone even down, or of the same range somewhat. So here the syntax is, so I have to make a histogram for only one of the my y variable, sorry, x variable, but only thing is that it has to be at a certain level, so divided by these groups, plural, d plural. So for that, what I have done is I've made a layout of 1 comma 5. So that in that way it has grouped my level, and in this way I can show it like this. So this feature is available with histogram with this lattice package that I've provided, that I've used previously. Now let us use some other thing. So is childbirth associated with the kind of delivery that the child had? So it doesn't make much of a difference. So all of them seems to be in the same position. So a bit of variance is there, but more or less it seems like a similar way, or a similar kind of distribution for each of them. So let's make a density plot of it. So it will actually make a smooth curve of it. So for histogram, we only have a certain range. So if it is from 10 to 12, then put it into a certain bucket and then plot it. So for density plot, it would be a bit more different. So let us do a density plot here. So as you can see here, yeah, so as you can see here, for single, again the average wage, average weight or the distribution of the weight is a bit more compared to other counterparts that we have or the other factors that we have. Single has a much more average weight compared to twin, that compared to triplet, and that compared to quadruplet. So the distribution shows like this. So again for density plot, the things are same. Only thing it was separated by a pipeline, D plural. I have made it a here I have made it using groups. So groups of D plural. Now let's do a dot plot. So dot plot will only make a density of dots that are present there. So let's do that. So actually data set is quite large, so it's taking a bit of time. So here it is. So you can see the number of people who are born as single, that percentage is quite high. Twins are little less, and also the weight is more on the lesser side. Singles have a distribution of quite high, so it starts from some lower value and also goes till some higher values as well. For twins, this is the higher and the limiting value. For triplet, it is less, and again for higher factors, it even goes down. So let's make a week-wise distribution and see XY plot for weight during the birth and also the week that is that the child was born, the date of the week that the child was born. So here you can see there is no such variation in that way. A few of the points has quite higher for the weight part, but again more or less it resembles in a similar pattern, nothing much different. Now I'm adding one more level to it. I'm adding how many were born together. So let's add the plural factor to it and let's see and let's analyze what it shows. And also one thing that because I have to accommodate all the plural factors, so I have made a layout of 1 comma 5, so that will accommodate all of them. So this is how it look like for all the levels, as you can see. So for single, the weight distribution is quite natural and how it should be. For twins, it has reduced a bit. The average weight has reduced a bit. Triplets, it has even gone down. Quadruplets, I have very less numbers to show. So and also those numbers are in very less range. So the weight is quite less for all of them. And higher factors, it's even lower. So it shows that actually the kind of or the plural factor does play a role with determining what would be the weight of the child. So let's say, so here I have another factor here, the weight gain of mother. So what would be the weight gain, and is it associated with the child of the weight of the child? So let's take a look at that. Let's see what it represents. So a kind of a scattered association, but it doesn't give a good picture around. So I can say that most of my points are associated somewhere here. So average weight of child would be somewhere around 4 kgs here, and weight gain doesn't seem to have much of a uh, association with it. So it is clustered around a single point. So let's divide it in different levels of birth, a plural factor, and let's see what it shows then. So for adding a factor to it, just use a pipeline and then plural, d plural. That will do. And because I have to make it to a 5 level, I've made a layout of C 1 comma 5. So yeah, it's taking a bit of time. So here it is. So again, the kind of association that I can see is a bit too random, or the points are so associated that I cannot make any difference out of it. So in this way, so it becomes a bit uh, difficult to interpret how should things be seen. So there we have an option of smooth scatter plot. So smooth scatter plot will actually make a density plot of this. So for where I have more concentrated points, those part will be more darker, and compared to where I have lesser points, those points will be lighter. So let's see smooth scatter plot. So yeah, this is how it works. So weight gain of mother and weight of the child with which it was born. So here I have more denser points. So no more number of points are concentrated here. And is there any association? So a slight increase in the number, or you can say it is a bit inclined upward. So I can say a positive feedback for between the two, or for the positive relation between the two. So there is slight association. So I expect if the weight of child is more, then weight gain by mother would be a bit more on a higher side. So box plot is one of other more visualization technique that is used. So it is mainly used for okay, okay, okay. So there is lag, I think. So all of you, so all of you are experiencing that lag, or is it okay? Sujata says no. Okay, okay. So let's work with box plot. Okay. So box plot is mainly is used to see the range of the variable that we have. So here I can see the range of my birth. So let's say let's start with a simple thing. So box plot of dB weight, where I have data equal to this. So here I have, so this is a box plot. So it actually first thing is that this is from 25th percentile and to this is 75th percentile, and this is still the most extreme value. I think this goes up till the 99th percentile of the range. So here after this, if you have some very less numbers, so these are considered to be as your outliers, so which actually exceeds the normal expected range that you have. So this is mainly the one interquartile range, and this comes out to be even beyond that. So these are mainly that goes beyond what you can say is as an expected range that you would consider. So this is mainly for uh, uh, weight of the child during the birth. So this is how the, so these are, so as you can see, the normally expected range would be around uh, 3.5 kgs of weight. So that would be a normally a child is expected to have, and some of the ranges as you can see, so 8 kilos. Some child is born with 8 kilos, some is born with 6 kgs. So these are quite rare things to have. So yeah, as expected, these are quite high numbers, and these are my outliers. And also a child born with less than 2 kgs. So this is quite rare to have. Let's see with one another associated level. So this is also one of the associated level that is provided. This the description, I think APG. So this is a score that is provided. I think so. I'm not sure what is the utility of it, but yeah, we have to check with that. The actual utility for this, but if considering this, so this also has a bit of relationship between the two. So if it is this factor is 1, and then my weight is quite low. So the baby who is born with this factor, it is expected to have that the weight would be a bit less, a bit on lesser side. So for here, if I want to plot a make a box plot on different levels, so I just have to make a tilde between the two, and it will make a separate. So one will be my y variable and another will be my x variable. So in the previous case, I only had a y variable, uh, as you can see here. So this was only on plot of my y. So again, I need to have a different levels. So for that, I can associate with one of the more categorical variables here. So let's do it with the week that we have. So if I do it with different weeks, so weight is almost same. So it more or less remains the same with slight variation, but more or less it is almost the same and shows the same trend. So there is no specific relation between weight of a child and the day it is born of the week. So this was about box plot, and one more plotting option that comes with this lattice package is BW plot. So BW plot also works in a similar way, but it has some more features associated with it. So let's say I can plot this weight with these factors that I have, but at the same time segregating it with the gender of the uh, child. So that is one of the facilities that I have in BW plot. So let's run this and see. So here I have, so this factor was there, but at the same time it has segregated on the basis of gender. So that is one of the major feature that is available for BW plot. So again, the trend is almost same. So there is no much difference between, if you can notice, between uh, a female and a male. So let's make it on the basis of week. So this is something that we have seen earlier also. So let's do it using BW plot. So yeah, this is something that we have seen in the earlier box plot as well. It is almost same. So trend is more or less the same around here. So one more thing that we will be adding now is a T apply. So mainly if you have to make a pivot in R, so for that there are many functions associated. So one is aggregate function, another is T apply. So T apply is the one of the major function that, yeah, I have used most of the time. Table I have also used, but T apply has a lots of application and it belongs to the apply family. So we have S apply, apply, T apply. So T apply you can mainly associate it with the pivot in Excel or in any other programming language like SAS or even SQL. So T apply is actually a pivot equivalent in R. So what it does, it let me explain you. Uh, so this is actually my variable using which I will be which will be my variable. So if you all know understand SAS, so let me explain it that way. So here I am doing a mean. So let me show you. So this will be a proc mean statement. Then my variable would be this. My class uh, would be fac. So this factor would be my class, and then run statement. So this would be ideal equivalent in proc mean. And here I only want to show the mean, so obviously I have to assign, so with proc mean other variables also come out like number, so number of observation, minimum value, maximum value, min. So here only minimum or the average will be displayed. So this could be a proc mean equivalent of this function T apply. So let me not delete that so that you can use it for your reference. So let us do that. T apply. So as you can see, for each of the factors of plural or the birth that is associated with a single or a twin or a triplet, so I've got an average of the weight. So as you can see, as we have seen in our previous exploration, that a baby who is born single has expected to have a higher weight compared to a twin, compared to a triplet, compared to a quadruplet, and so on. Now let's say I want to add few more levels to my tapply function or make a pivot bit more complex or make it more explanatory. So what I can do is I can add few lists to it. So uh, as I told earlier, this would be my variable with which I want to make changes. So here the proc mean equivalent would be, so factor I have, and one more thing that I have is sex or the gender. So it will make a proc mean on basis of these two variables, factor and gender as well. So this is only difference here. So here what you have to do is you have to provide a list of those variables that you need to, on basis of which you need to aggregate upon. So let us do that. What T5 shows. So what all is the average weight for male and female and how it look like. So for female it is bit less, male is bit more for all the things. So here there is a bit of difference, but for triplet the number of data points is also quite less. So yeah, there is not much of difference. So here for quadruplet, female has quite more average weight compared to a male, and here it again goes back to the same trend. So let visualize it using a box plot. Yeah, Arun, it is like grouping it. So yeah, as I said, so in proc means, so this would be a possible SAS version of this command. So you must have worked with a proc mean also. So I think this would be a possible explanation how it works. So this is my variable that I'm working with, that is weight, and also these are the classes under which I'm making a aggregation or grouping. So let's do some visualization of this table. So T4 was only on the basis of weight and these factors. So as I know, the average weight for a single would be much higher than twin, then triplet, then so on. So it will drop. Now, if I want to see also on the basis of gender, then let's see. So here I have also two levels for gender. So here I have mentioned beside equal to true. What if I might make beside equal to false? So it has aggregated on the same level. Or you can say, yeah, this looks too good. So again for single, it is at the highest and then it goes down. A similar trend. So this is also one of the factors there. So let's see what this factor is all about and what is the description provided for estimated weeks of gestation. So there I have estimated weeks of gestation and what is the number so associated with each of them. So 12 weeks is 1, 15 and so on. And it goes like this. And we have some maximum value somewhere around 30, 31 weeks, 32, 33 weeks, so on till 38. So here we have largest number and 39 week is the maximum highest expectation, and then 40, and then it goes down again. So let's say if I make a plot of it and understand how it goes. So plot and density. So here actually it is a discrete value. For this reason I think it's there is a up down every time. So otherwise you can see that at 30 39 so 39 40 we have a maximum expectation. Otherwise these are quite less value, and this is extreme, very extreme value. We are not expected to have this, so it is kind of very rare, and we can exclude this from our analysis at the moment. So let's do one thing. Let's remove this one which 19 with 99 and save it in a new table or a new data set. And now if I want to make a table of it, and let's see. So here I have removed the one with 99. Now let us want to make a summary of it, and let's see what happens. So it's associated at different levels. So this was all about this data set. So let us move on to one more data set that I have. So this is this one I think I provided in the path which is there. So this one was about a contribution that was made by alumni to a college, and I've saved it using Dawn. So using a donation as the abbreviation for this. And same we will be working with lattice also here. So let's see how the data looks like. Yes, closing this orange juice also. So here I have details of the students. So what is the gender and which year they passed out. So and also what is the marital status, what is the major that they have chosen in their college, and did they pursue any next degree. And then did they contribute in fourth year, after third year after passing, second year after passing, so first year after, and the year they passed, attendance of the event. So there was an alumni meet or a reunion, you can say, and how many of them attended. So is it a yes or no? So like this, T giving is actually a variable that we will use later on. Uh, so T giving is actually the total donation that has been made. So it is actually sum of the donation in fourth year, third year, second year, and so on. So let us work with this data. So classes that I have. So I have people passed out in 1957, 65, 77, 87, and 97. So let us look at the bar chart of this data and let us try to understand. So, so in the previous bar chart, you must have remembered that in C-section part that we did earlier, here we had bar chart in a bit different format. So it was actually made in horizontal format. And then when I put horizontal equal to false, then the orientation changed. So by default, horizontal is true. So if you make it horizontal equal to false, then only it will uh, provide you data in or the figure in a vertical format like this. So, so the number of people that I have from 1957 is less, then it increases with every passing year, every passing decade, I would say. So let's say I want to make a new variable, total giving, which is actually a sum of all the donation that has been made by these uh, students, or you can say this alumni. So I have this. Now mean of this variable. So a mean is around 980 and standard deviation is quite high. So that means it is so there are quite extreme values that I have in my distribution. So standard deviation, I think I've done this in previous class, and there, and now the picture actually comes here. This role of standard deviation. So suppose I have a mean of such a low value, and I have a standard deviation of such a high value, that means that there has been quite high variation compared to with respect to my mean. So let us see what is the distribution of actually this t giving. So these are my quantile. So actually what happens is it gives me a increment by, so here I have set sequence from starting from 0 to 1 and incremented by 5%. So or 0.05. So that's why my quantile is increasing by 5% every time. So for first I don't have any or much of the values here. Then I have some $10, you can say, then 25, then so on. Then it keeps on increasing, and then the 100 percentile, the one has paid a lot, has paid somewhere around 1,71,870. So this is the highest value, and for this reason we can see that the standard deviation value is quite high compared to our mean. And let's do it only for the quantile range of 95 percentile to 100 percentile. So you can see even here also you can see there is a lot variation. So it starts with 2200 and goes till 1,71,000. So there has been an only with this variation from 99 to 100 percentile, there has been a big jump. So let us plot and understand how this total giving look like. So as you can see, most of my points are concentrated at a point which is something half of 50,000. So this is 25 and not even so 99 percentile uh, that mark is touched by 16,000 donation. So that means that all the things are covered in some 20,000 only. The only one value that goes so high. So let us subset our data and then try to understand that how it goes. So what I'm doing here is I am subsetting my data that my total giving should not be null or should not be zero. I shouldn't have a total giving of zero, and also it should be less than 1,000 because most of my distribution are within 1,000. For that reason, let's check only this distribution and understand what has been the trend. So let's say starting from minimum value, and then so we have seen some of the values like 10, 25, 50 that comes in this range. So these values are quite high, or these donation are quite high, and then followed by this. So it goes down like this. So highest contribution towards here, and then it goes down with the increasing price or the increasing amount of donation. So now let's make a box plot of. So we have already seen that there is a quite a high outlier there. So 100 percentile comes at 1 lakh and 99 at 16,000. So we are expected to have some good outliers there in box plot. So let's see. So yeah. So when you see, so most of the points are concentrated here. Only few of the points drag down to such high values. So my entire box plot is only concentrated at such low points, but only due to this thing it is showing like this. So if even if I zoom out, I can see it like this only. So let me make it on a relative scale. So for that I'm making it outline equal to false. Let's see what happens. So only on a relative scale. So this is how it looks like. Only considering for 0 to 1,000. Now let's say let's subset the data and have the numbers only till 30,000, and let's make some analysis. So here we have some data also, 6 more variables, and so here I have selected the first five columns, and along with that the 12th column that I have. So 12th column will be of total giving. So let me see what I have. Yeah. So I've omitted out a few the year-wise giving or year-wise donation, and I've aggregated it to total giving or the total donation that they have made. So if I sort it by in decreasing order, then this is my highest, and then it goes down. Now let's make a box plot of total contribution with all the years, all the students. So you can see the most eldest alumni that we have made the highest contribution. Then it has reduced, then and most recent alumni has made the least contribution. And this is quite obvious. So alumni who has settled down and is uh, towards its retirement, so he would be able to make more contribution compared to one who is quite recent or quite new as a alumni to the college. Let's see if gender makes any impact of donation. So male is expected to donate a bit more on an average. Male is expected to donate a bit more compared to female. And let's see if marital status makes any impact on uh, the contribution that they make. So married, so divorcees make less contribution. Singles. So one thing can be seen that most of my recent passed out are expected to be single. So most of them who have passed out recently, and we have seen that for them the contribution was minimum. Same thing, I can see the trend here also. So for most of them who have passed recently or who are single, the contribution by them would be minimum. And that is quite in line with what we have seen earlier. And widowed, so widow would be actually someone who is quite old to the college. So only after a certain age you will be widowed. So even when compared to when we are compared to the age or the decade in which they passed out, that is also quite in line with this contribution that they have made. So widowing all only occur at the age of on the late age, or let's say even or near to your retirement in 60s or 70s, and these are the people who have donated largest to the college. And attendance we have, so the data that we have now was gathered during reunion of all the alumni. So the one who attended the session or the reunion are the one who contributed more, and the one who did not attend the session, so the contribution to from them was least, though some of them contributed, but it was on the lower side. Now let's again do a T apply. So again here, this is my variable and this is my class. So with major, that means so what was my major, or what was my area that I studied in my college, and what does it has anything to do with the amount of donation that I provide. So let's see that. So here we have American studies, anthropology, art, biology, and everything have a certain number associated with them. So comparative literature has 0. So nobody from this department contributed. Similarly, general science, physics, nobody contributed from here. So let's see what are all majors and what is the distribution of all the majors that we have. So these are the number of students from this departments that we have, or these majors. Let us now combine these two and understand. So for that, combining two data set along the column, we have the command is cbind. So cbind actually what it does is, suppose I have a data, one data looks like this. So this is the data of one data set, and cbind actually adds both of them side by side. So it is not a join, so it is just a side by side concatenation of the table. So these two will be added and that will become into a single table like this. So after addition, these two will become like this. And there is something called rbind in R. So rbind will actually, so you must be knowing append function or proc append in SAS. So rbind works in the same way as append. So if I have two data sets like this, so rbind what will it will do? It will concatenate row wise. So row wise concatenation. So like this. So the new data set will be row wise addition of both of them. Something new which will be addition of this two. And it becomes something like this. So let's do cbind here. And I'm only including those departments which are more than 10. So have a strength of more than 10. And now ordering them in the decreasing order. So this is according to the total contribution that has been provided, and also this strength of this mm, batch or this department has to be more than 10. And let's visualize this and see. So here I have made it only on the basis of the donation that has been provided with different from different departments that I have. From all the department, what is that contribution? Now let's see one more example that does next degree or pursuing higher studies has anything to do with the donation that they provide. So let's make a table of it and let's analyze. So these are the higher degree that they have pursued. I have some values none as well. So none is also, so the one who haven't made any higher studies or any efforts with that, even they have contributed something on an average or a total. So let's understand here as well. So if I see the next degree wise, so these are all the distribution that I have. So LLB, JD, LLD, MA. So here also I will be subsetting few of them. So only considering who are more than 10. So one who have so the degree that has been pursued by more than 10, I will be only choosing them. So let's do that. Here. C bind and choosing only which is uh, more than 10, and then ordering them according to the donation that has been provided. So the one who does MBA provides the most, then JD, then MS, then MD, PhD, and so on. And now if I see this in a bar chart, so the one with MBA has contributed highest, and then followed by JD, and then the rest of the. And let's see if I want to make a density plot of this. So T giving along with the factor that is my class or the year of the class that they have passed out, and also considering the data I have trimmed the data, so I'm considering only the total donation that is more than 1,000 and sorry, less than 1,000 and more than 0. So that is my range that I have uh, figured out for this. So as you can see, I have provided a pipeline of factor. So it has made a factor of this of class year, and on basis of that, it has provided a density plot for each of the year. So there you have some donation. So here the density is quite high, or there is a spike. But overall, if you see the strength towards the more donation or 500 or something like that, it's more here. Then there is a spike near 0, but then it goes on like this. Then again there is a high spike near 0. So most of them I haven't donated, and then it goes down. Then again in 85, 87 there is a high spike near 0, and then it goes down. So most of them haven't contributed. So no contributes here are less, then here they are more, there even more, and even more. And here there is no data that seems to be seems on which we can work on. So there are very less people who here. So this is the sum of all the donation that has been provided by the alumni of respective years. So this is for 57, 67, and as you can see, 97 is the least, only counts to 35,000. And let's make a bar plot of it and understand. So on a comparative scale, this year, so alumni of this year have made the highest contribution, and then it goes down. And that's why in the previous density plot, we did not see anything significant here. First reason being that number of students for those years were quite less, and also the donation coming from them is very less significant. Now let's make a bar chart every year. So this is my uh, T apply, and that is I'm doing for the uh, year that the person has provided a donation. So first 0th year, first year, second year, third, fourth, in this way. So every time that donation has been provided, I will see what has been the distribution for each and every year. So this is for fourth time, or the uh, FY04. So this has been the distribution. So 57 is still good, but 67 has provided more. Then do it for next. Now 57 has provided highest here. Now then move on to next. Again 57 is the highest, and then goes on. Then again 57 has provided the highest. And again. So this has been the distribution for various donation that has been provided in different years, and the sum of that with aggregated on a yearly basis on the year which the students passed out. So that was the basic visualization of this data set. So this will be our last data set for today. So here we will be working with orange juice. So the data set that we worked previously for previous sessions of R. Okay. So here again we will be working with lattice and visualization of the data. That will be the main theme here. So I've made a factor of all the stores and then stored it in uh, store variable of orange juice. Let's see. So I've selected only first two columns, and there I have all these variables that we already have worked with. Now let us make another T apply. So there the variable I have is log move, and according to brand, it will be aggregated on the basis of brand. Function using mean, na.remove. That means if my data is null, then it will be removed. That is true. So let's see. So this is the average value of log move for different brands. And let us do it on week and brand level both at the same time. So there I can see a lot more. So it starts with 40th week and goes till 160th week. So there I have some 120 distribution, 120 weeks. And for every week I have some different values of mean of every brand. Now, so this is a simple plot of the apply function that we have got. So this will be plotted according to weekly. So here I've made a type equal to L. So that means it will be a linear, it will be a line graph that will be plotted. I will be plotting with weeks and this brand only, Dominic brand only will be there. So with each and every level I will be considering my other brands as well. So let us do this by brand. So let me, so it has been like this. So starting from week, now let's say this. So here also some similar trend, linear graph with all the weeks. So as I said, we have 120 weeks. So starting from 40th till 160 again for Tropicana. Now, one more thing that I want to mention, that if in case if I want to make all the three distribution in the same chart, then for that there is a command par mf row equal combination of 1 3. So it has come out like this. Now let's say I don't want it in this way. I want it to be like this. So three rows, not three columns. So I have to change it to three rows. So this will be my three rows and one column. So first, second, and then third. So this is actually a good technique to accommodate one more than one graph in a particular manner. So let me set it to 1 comma 1 so that I could get only one graph. So let me make a vector here for log move and week. Let me make a XY plot. So as you can see here, uh, log move across different brands that we have. So we can do, so the way I said that can be also used, and this method can also be used. So this method was using lattice, and previous method which I showed here, that was without using any package. So that was not reliant on any package. The one that we did next, this was reliant on lattice. So let us do a box plot now. So average for all of them are almost same. So Dominic has a larger distribution. It covers larger numbers. Minute Maid has a similar average, but distribution is a bit lesser. And Tropicana is quite limited. Let's make a histogram of this and then understand. So as you can see, uh, Dominic is more like a normally distributed. This is more skewed, and this is also a bit more skewed. So this shows the distribution of all three uh, categories or the brand under different conditions, under different log move or log move values aggregated. So let us make a density plot of log moves with different brand. So as you can see, this is more of a normal curve. This is more skewed, and this is a normal but bit typically slightly skewed, I would say. So when all of them are to be superimposed at the same time, then you can provide groups equal to brand. So this will actually superimpose all of them together. So log move, if you plot it, so this doesn't make much of a sense. So because all of them are clustered around the same thing. So this doesn't show you how it look like. Again, this is also a similar kind of distribution. So for that, we have discussed that if points are so congested at a certain level, then smooth scatter plot could be one of the alternative that can be used. So again, doesn't make sense. So what here we can do is we can work with smooth scatter plot and understand how it works. So here you can see the more points are distributed around this, and a kind of trend is like this. So it starts from here and goes like this. So this gives a bit of idea about the trend of this line or the way it behaves. A density plot of log and based on the features that we have. So it has been grouped by features, and now XY plot of price, and then group, and it has been grouped by the features. And let's say I have filtered out one of the store and I only want to work with them with that. So let's filter out for only one store. So uh, how it behaves for different weeks. So I have filtered out only store number 5, and for that I am seeing how has been the trend for all the different weeks that I have. So this is also a density plot for different brands that I have, and based on the log move values for different features. Now let's do a few of the alternation here, and then it will be closure for the day. So let us apply a pivot here and make it on income. So I will be aggregating income on the basis of stores. So let's do that. So I have here starting from second store to 137th store, and I have aggregated them on the basis of the income that they have. And here I am choosing out the max one from this and min one from this. So max that I have is 11, and min that I have is 9, 9.86, 11.23. So 62 is the store number, 75th is the store number that I have here. So let us filter out them and work with them, and let's understand how this looks like. So here I'm making a R bind or row bind of 2. So if I see OJ3, so all the store number with 62 and 75 has been stored here in OJ3. Now let's see them. Now suppose if I want to make a summary of it or a regression line of it, so here is the uh, command for that. So that is lm linear model, which actually makes a relation between log move and price, and the data set that I have is OJ1, and let us work with that. So summary, it shows that it doesn't comes out to be a significant uh, factor or a significant contributor to my model or the explanation that I have. So let us remove that. So this is the plot between log move and price, and if I want to fit a AB line or a line which actually shows the trend, that I have this command AB line M high, which actually shows that not much of a variation is there between the two. So it is actually a steady line. And from the second data set, let's do that again. Now I show the AB line. So there is slight bit of variation between the two. So this was all about. So I know it was a bit lengthy, but so most of the thing has been covered